Okay, folks, just a couple of rules about negative exponents. So if you have a number here and you want to figure out, well, what would a negative exponent mean? So we want to keep the same rules that we've used before, where if you have the same base with different exponents, you add them. So we'd want a to the 1 times a to the negative 1, whatever that would mean, to be a to the 1 plus negative 1, which is a to the 0, and anything to the 0, of course, is 1. Well, what does that mean? Well, it means that a times something gives you 1, so that something we know is 1 over a. So whenever we see a negative exponent like this, it means 1 over that. So in general, it could be any number n. A to the negative n is 1 over a to the n. Another exponent rule to do with fractions is, what if you have a whole fraction to an exponent? Well, what does this mean? Exponent means multiply the base. In this case, our base is the fraction a over b. Multiply the base by itself, exponent number of times. So it's a over b times itself n times. So what does that mean? We know how to multiply fractions. You multiply denominators, so it's a times a times a times a times a n times, and the denominators b times itself n times as well. So if you have a fraction to the power of n, then all it is the numerator to the power n over the denominator to the power of n. Another exponent rule I want to talk to you guys about, if we have negative exponents of fractions. So in this case, we have a over b to the negative 1. Well, if we multiply a over b to the negative 1 by a over b to the 1, we'd like that to be a over b to the 0, and anything to the 0 we say is 1. So what does that mean? Well, what when we multiply by a over b do we get 1? And the answer is b over a. You can see here the b's cancel out, the a's cancel out, and you get 1. So that means that a over b to the negative 1 equals b over a. Another quick reminder, just to kind of help us out here, if you have a fraction divided by another fraction, well, you can write it as a division like this with a divided sign. So a fraction of fractions, you can write as a fraction with a divided sign. And then we know how to deal with that. You take the reciprocal of your second fraction and you multiply. And just another few rules I want to talk to you guys about, just to remind you guys. So if you have, let's say, two natural numbers. Oh, in fact, let's make them integers. Why not? But we'll say 1 isn't 0. So if we have integers like that, I don't even know if I'll use b, but I'll put it there anyway. So then we have that. Well, if we have anything over 1, that of course is the same thing as that number. So 2 over 1 is 2, negative 5 over 1 is 5, whatever. Also, anything over itself is 1, but you can't have 0 over 0. So let's say for a not equal to 0. And the final thing I want to say is 0 over a equals 0. So 0 over anything equals 0. Again, we can't divide by 0. So for a not equal to 0. Now let's do an example of using these rules just to make sure we understand what's happening. So with this example here, we have one fraction divided by another fraction. Well, this fraction is squared, so we're going to have to simplify that. So our plan is going to be to square this out first, Then we can look at taking this fraction, writing it as a divided by problem, and then simplifying through using our rules of exponents, and we'll go from there. Our end goal is to write this so that there are no negative exponents anywhere, and it's just written as much as we can as one fraction of numbers. All right, so let's go ahead. So let's square the bottom first so the top stays the same. And then remember to square the bottom. All we're doing is we're going to multiply our exponent by each term in the numerator and denominator. So let's go ahead. So we have 3 squared squared, so 3 to the 2 times 2 is 3 to the 4. 5 to the 2 times 2 is 5 to the 4 over 2 to the negative 2 times 2 is 2 to the negative 4, and 3 to the 2 times 2 is 3 to the 4. So we've simplified that. Now let's write this as a division problem where we'll multiply by the reciprocal. So I'll do this kind of in one step. What I'll do is I'll write down my top fraction here, and then just divide it by the second fraction, which is like multiplying by the reciprocal. So this is the same as 2 cubed, 3 to the negative 1 times 5 squared over 3 squared times 5 to the negative 2. And I'm going to multiply that by the reciprocal of the bottom fraction, because we're dividing by a fraction. That's the same thing as multiplying by the reciprocal. So let's go ahead. So it's going to be 2 to the negative 4 times 3 to the 4 over 3 to the 4 times 5 to the 4. Now, in some sense, we have two options here. Both of them, I'd say, are as good as each other. We can multiply the tops together, multiply the bottoms, and then simplify, or we can simplify individually and then multiply the tops and bottoms. And if we have to simplify, once again, we'll do it. But I think for this, we're going to multiply our tops, multiply our bottoms, then simplify. It saves one step of simplification. So let's go ahead and do that. So we have 2 to the 3 times 2 to the negative 4. So that's going to be 2 to the 3 plus negative 4. So that's 2 to the negative 1. 3 plus negative 4 is negative 1. And we keep going as such. 3 to the minus 1 plus 4 is 3 to the 3. And then we just have 5 squared. So 5 squared times, you can think over here in that second bit, if you like, is 5 to the 0, because anything to the 0 is just like multiplying by 1. Okay, so that's our top simplified. Let's simplify our bottom. So we have 3 squared times 3 to the 4, so that's 3 to the 6. And then we have 5 to the minus 2 times 5 to the 4, so that's 5. So minus 2 plus 4 is 5. Minus 2 plus 4 is squared, so it's 5 squared. Great. So now we have some negative exponents. So let's simplify this as much as we can. We can cancel out some 2's and some 5's, so let's go ahead and do it. So we only have the 1, 2 here, so it's 2 to the negative 1. And then we have 3 cubed divided by 3 sixths. So remember, when we are dividing fractions, we have 3 3's up top, 6 threes down the bottom. So just remember here, in this step here, we have, how many threes do we have left? Well, we're going to cancel out 3 of them. So it's going to be 3 to the 3 minus 6. And here we have 5 squared over 5 squared, so it's 5 to the 2 minus 2. That is this bit here. And we simplify this, so this is 2 to the minus 1. 3 minus 6 is minus 3. And 2 minus 2 is, in fact, 0. So we don't even need to write 5 to the 0. We can if we want, but remember, this bit here just equals 1. Anything to the 0 is just 1. So let's simplify this. So remember, negative exponents are like going in the denominator. So we have a 2 and a 3 in the denominator. So this is like 1 over 2 times 3 cubed, which you can check is 1 over 54. So after all that simplification, we have our final answer as 1 over 54. And just as a quick reminder, just to make sure we get this, remember, if you have a to the b divided by a to the c, that's the same thing as a to the b minus